The focus of this lesson will be how to create and use variables in the script. So let's start with a classic definition of a variable. A variable is just a name pointing to some area in the memory, where the value of that variable is stored. When I create a variable, I write something into the memory, and when I use a variable, then I get the value from the memory. Variables simplify the script because they allow to reuse the same value in multiple places. They store temporal results returned by the external program, called by the script, and so on. The bash shell itself has already a lot of variables. We can display them executing the set command. The output will be quite big, so let's pipe the output to more. There is a lot of variable names and values here, so let's just shortly recognize the meaning of some of them. A variable bash. The value contains the path to the current shell that we are using. As we are using indeed bash, we can see here path to the bash shell. Here we can find information defining the number of columns in terminal and the number of rows. Here there is the definition of the bash history file path. And how many commands are saved in the file? This could be checked in the variable hist size. Here 1000 recent instructions. The huge complicated variable at the bottom contains information used while we execute the ls command and when the output is formatted. That's nice to have directories in one color, executable files in other, and so on. The definition here is used for that. And so we could continue reviewing output of the command, but it would take quite a lot of time, because apart from the simple variables, values, we have here also definitions of some functions. All those definitions are somehow used by shell or dependent programs. So for now, we have seen variables that were already defined for us. Now we can try to define a variable by ourselves. Creation of the variable is so simple that the hardest part is to find out a good name for it. And trust me, this is not always so obvious. Let's assume that we are creating an installation script for an application, and this script needs to know from where to read the data. A variable pointing to such directory could be named import dir. You can follow some basic and simple rules when creating a variable. Usually the names are given in uppercase. That's okay to use lowercase, however, there are different schools teaching how the variable should be defined. I like to keep them in uppercase, as then it's easier to find such a variable in the script. From time to time I decide to use also lowercase, but that's mostly for less important variables in the script. Some people would keep parts of the name together. Import stick with dir, but I like to have them separately. That's why I use underscore. Variables should not start with digits and should not contain special character in the name, but in short, if you like problems, break all those rules. After entering the variable name, write equality sign without any additional space. In other languages we are sometimes encouraged to use the nice spaces, but here that would cause an error. Don't do it. How to use the variable name? It's easy to, but you need to remember a few rules. When getting the value of the variable, add at the beginning the dollar sign. If you are lazy, you can enter just few characters of the name of the variable and press Tab key. If only the initial letters match to only one variable, bash will generate the full name of the variable for you. Just a kind of a simple IntelliMatch in Shell edition. So, the instruction echo $import dir displays the value of the import dir variable. One of the errors that you can make in such operation is that you could type just $variable without the echo command. You may hope to see variable name or variable value on the screen. Unfortunately, that will cause an error. Bash thinks that you want to start a program stored on disk in the file tmp import, but there is no such file. Here, such way of thinking caused error, but generally, this shows the great power of variables in shell. Once the variable is defined, it can be used in other commands, programs, scripts, as a parameter or just as a name of the program that should be started. That makes our script agile. Let's see that example. Here command cat will redirect keyboard to the file defined by the path taken from the variable import dir. In the file I will put the echo statement printing something on screen. To treat a file as a script, additionally we need to change permissions. Also here the file name can be defined by a variable. What will happen now if I, let's say, by mistake type in the command line the name of the variable? As you see, there is no error. The variable points now to an executable file, a script, and this script was loaded by bash and executed. Nice, isn't it? Finally, the file can be removed, and in this case again, a variable can be used. Why not? When building a script, consider adding lines telling something about the progress of the work. With time, having the screen full of messages may become annoying, but at least at the beginning may be really helpful. In the messages shown by the script, you can also add the value of a variable. For example, when the script is going to create a directory, a message "creating directory" can be displayed. If you put the message into quotes, then bash will take a look into the string that should be displayed, and if a reference to a variable will be found there, it will replace it with current variable value. The text displayed in the console does not contain the $import dir. The reference to a variable was replaced with the text tmp import. That's very good. I like it. However, if instead of quotes I will use apostrophes, then bash will take a different action. Now the hidden bash intelligence was disabled and the text was taken as is, so now I can see just the variable name in the message. Usually that's not what we want to have, but also may be helpful in some situations. Let's check if that's possible to build the text so that when we display it, both the variable name and the variable value would be shown. We can imagine a crazy script where not only the current variable should be shown but also information about the variable that is used at this time. That sometimes is used for a simple debug of the script. Unfortunately, if I decide to embed twice the variable name in the quotes, as it is now shown, the result will be that bash will twice replace the variable name with the value. Oh no, that's not something what I want. So maybe apostrophe would be better. Let's check. No, this time bash decided to show twice the variable name. So what to do? First, indeed use quotes. Bash needs to be instructed that the text may contain variable name that should be replaced with its value. Second, whenever you want to display dollar and something more, precede the dollar sign with a backslash. Now, dollar loses its special meaning and is treated just as a normal letter. Now, the text returned by echo is finally as I wanted to have it. To be more precise, in the examples shown here I should not use the word variable name. Whenever the variable name is preceded with a dollar sign, it's no more just a name. It's an instruction for bash to show the value. The next example that I want to show will create some entries in the system event log. The system logs can be stored in different locations, for example in var log syslog, but in my case, on my system, Red Hat, that's var log messages. That's one of the favorite lectures of system admin, and here a lot of information can be found telling the admin what has happened on the system. When I want to add entry in the log file, I should use a command logger. As a parameter, add the text that should be added to log, and that's all. Now the new entry is visible in the system log. Okay, now we can start building a script that should install a fictional software on my machine. I will start with shebang. Now I will define variable import dir. Here I will store path to a directory that should be created. In the variable mode 700, I will hold the numerical definition of permissions that should be later applied on a directory. The owner will have full permissions, but the others will not be able to do anything. Someone who doesn't know variables could now write commands. Display a message with a hard-encoded directory that will be created. Next, create that hard-encoded directory. Display a message informing about permissions change with hard-encoded directory name and permissions. Change the permissions on hard-encoded directory with hard-encoded permission definition. And finally, send a message to log with a hard-encoded directory name. But we know variables, so instead of hard-encoding variables, we are using $, and variable name. Now the messages are built on fly, while the directory is created or permissions are changed. Moreover, if with time someone would like to change the directory path, such a change will need to be done only once in the second line of the script. All the instructions below will just use the new variable name. Define once, use multiple times. That's one of the advantages of using variables. Such way of building a script makes it easier to modify the script later. For the moment, we will not handle any errors, so the exit code can be 0. Let's see if that script works. To start it, I need first to change the permissions. Now the script can be started by entering a relative path to it. Note, the script has started, displayed on screen verbose messages, and hopefully created the directory and also changed permissions to it. In the messages, I can read the directory name and the permissions definition. There should be also a new entry in the system log. Well, the file is accessible only for admin, but that's not a problem. Sudo at the beginning should make the work. Indeed, the last message was generated by our script. The last check can be done on system. Was the directory indeed created? Yes. So in this lesson you have seen how to create variables and how to use them. There was also an opportunity to check how logger works. The following lesson will continue the topic of variables. However, we will take more detailed look at the system variables. See you!